Hi there, I have an interesting system of equations problem for you, and let's see how we can tackle this problem. So first I see that x and y is symmetric on both equations, so maybe I will use this in the end. And so the most annoying part in the problem is the square root of x and y. So to get rid of them, let's substitute square root of x is equal to a, and square root of y is equal to b. If I do that, in the end I won't have any square roots, okay? So let's rewrite the problem. I have 3a squared plus b squared, a squared plus 3b squared, ab being equal to 14, and I have a squared plus b squared, 14a squared b squared, and this is 2 plus b squared, b to the 4. This is equal to 36. So now I'm just opening both sides. This is just algebra. So I have 3a to the 4, and if I also multiply it by ab, it will be a to the 5b, and middle term will be, so if I multiply this by second, it will be 9a squared b squared, and if I multiply this by this, it will be 1a squared b squared, so it will be 10a squared b squared, and if I also multiply it by ab, it will be 10 a cube b cube, a cube b cube. And this is just symmetric, so the next term will be a times b to the 5. This is equal to 14. And if I open this side, it will be a to the 6 by multiplying this. So from this first and second, I will have 14a squared, a to the 4b squared. And if I multiply this thing, it will be 1 more, so it will be 15 a to the 4b squared. And similarly, it will be 15 a squared b to the 4, and I will have b to the 6. So here it should ring a bell on you. Okay, look, I have powers of 5 and 1, 3 and 3, 1 and 5, 6, 4 and 2, 2 and 4. So all of these powers are adding up to 6. And also look at the constants. I have 1, 15, 15. This is also 1. And these ones are not that good. So let's write the Pascal triangle and let's see what's going on. So I have 1, 1, 1, 2, 1, 1, 3, 3, 1. 1, 5, 10, 10, 5, 10. I'm almost there. 1, 6, 15, 20, 15, 6, 1. So I know that this is for the powers of 2, 3, 4, 5, 6. So this is for the powers of 6. Okay, let's write it like a to the 6. So I have 1, 15, 15, 1. So this satisfies the first part. This satisfies the second equation. But I don't have 6, 20, and 6 on the first part. But I have 3, 10, 3. So this is just half of it. So if I just multiply this equation by 2, I will have expansion of a to the a plus b to the 6. Okay. So if I just take the second equation and add 2 times 1, 2 times of the first equation, 2 times 14, this will be equal to a plus b to the 6. It will be a plus b to the 6 expansion. And so I have only odd terms here, the first, third, fifth, and seventh. And so if I actually multiply it by minus 2, I will get a minus b to the 6. If I do 36 minus 2 times 14, this will be a minus b to the 6. Because if I only have a plus b to the 6 is equal to something, I don't know what is a plus b. But now I will know it. So let's see. This is equal to 64, and this is going to be equal to 8. So from here, I can say a plus b is equal to 2. And from here, also, and note that I said square root of x is equal to a, and square root of y is equal to b. So anything square root is greater or equal than 0. Okay, so I'm not saying a plus b can be minus 2 or something. Okay, and from here I know that a minus b to the 6 is 8, so this is 2 to the 3, and if I take 6th root it will be square root of 2, so a minus b is square root of 2. So if I just add both of these equations up, I will have n divided by 2, I will have a being equal to 2 plus square root of 2 divided by 2, and b being equal to 2 minus square root of 2 over 2. This is just, I just added both of them up and divided by 2, and here I just subtracting both of them and divided by 2. So now I'm almost done. I knew that this is equal to square root of x and this is equal to square root of y. So I want to solve it for x, so let's square both sides. I have x is equal to 2 plus square root of 2 over 2 squared. So if I just do this, I will have 4 plus 2, which is 6, plus 4 square root of 2 divided by 4. And on the second part, I will have y is equal to, so I'm just squaring this thing and I will write it directly. This will be 4 plus, so this will be 4 plus 2, which is 6, minus 4, so this will be 6 minus 4 square root of 2 divided by 4. So if I simplify them, this will be 3 over 2 plus square root of, this will be just square root of 2. 4's will cancel out, and y will be equal to 3 over 2 minus square root of 2. So that's it, I solved it. So let's say xy, but I will also leave one more note now. So I found x being equal to 3 over 2 plus square root of 2, and y being equal to 3 over 2 minus square root of 2. So in the beginning I said x and y is symmetric, so there is no reason that I can change this x and y in the beginning. Okay, so I can just change this one here and this one here, and I can write it by simply saying this can be minus and this can be plus. And what this means is that one of the roots of xy is 3 over 2 plus square root of 2 and 3 over 2 minus square root of 2. So this is the first solution. And the second solution is 3 over 2 minus square root of 2 and 3 over 2 plus square root of 2. Okay, so if this is plus, this is minus. If this is minus, this is plus. And that's the end of it.